All right, folks, welcome to Yak Math Videos for your first calculus video of 2018. Before we start, I'd like to thank our 2018 mega sponsors here. We have Cliff Bars, Laura Bars, Garmin, Fitbit, Caldi Coffee, Chinatown, Ruby Tuesdays, Starbucks, and Tazo Zen Tea. Again, please email Yak Math Videos if you want to be a premium mega sponsor this year. All right, since I am out today, calculus, here's what we're doing. We're going to finish up our notes from yesterday, and you are getting, as you should have now, your first homework sets of the year. The few examples I'm going to go over in this video will help you on questions 11 through 18, all right, in that homework set. And then on Monday, I will come and we'll just begin with the other stuff, all right? You should have no issues with turning in that homework set next Friday. All right. We talked about the mean value theorem yesterday, folks, and that says that if f is continuous on the interval a to b and differentiable on the interval a to b, then there exists some point c that's in between a and b, such that if I take the derivative of my function and plug c in, I'm going to get the same answer as the slope from a to b. All right, now as we learned yesterday from Rolle's theorem, if f of a is equal to f of b, then obviously, folks, if f of a is the same thing as f of b, then this is going to be 0. 0 divided by anything is 0. So, folks, these are here the same two things. But if f of a is equal to f of b, then f prime of c will be 0. All right, so I wanted to go over a few of those examples today to help you on your first homework set. Folks, this one, and you have a few like this, says check the hypothesis of Rolle's theorem and the mean value theorem and find a value of c that makes the appropriate conclusion true. All right, so first off, folks, this is going to make a lovely u, so it's continuous and differentiable. There's no asymptotes, nothing there on -2 to 2, so those two are fine. Plug -2 and +2 in for x, and notice that you get the same answer. So f of a is equal to f of b. Because f of a is equal to f of b, I'm going to use the Rolle's theorem there. That tells me that exists some c that if I take the derivative, f prime, and plug in c, that I'm going to get 0. So first off, folks, I take this function right here, x squared plus 2, and I find the derivative. All right, the derivative of that is simply 2x, power rule, and I set 2x equal to 0. All right, 2x equals 0 gives me a great answer. Now I want some value c, so that's c. Instead of x, I just would write c equals 0. All right, I simply take the derivative. I can use Rolle's theorem there because f of a, which is -2, is equal to f of b, which is +2. Again, pause this at any time. There's only a few examples. This video won't be too long. All right, take a look at this next one. F of x is equal to x to the third plus x squared on the interval -1 to +1. If I plug -1 in for x, I get 0. If I plug in +1 for x, I get 2. Notice that 0 is not equal to 2. I'm not going to use Rolle's theorem there. Instead, I'm going to use the mean value theorem as it's presented right there. All right, so I know what f of b is. F of b is 2. F of a is 0. So it's going to be 2 minus 0 up top. B is 1. So 1. A is -1. 1 minus a -1 is 2. So you'll see that. I write that right there. And then, folks, we also need to, so this is the right side here. This is the f of b minus f of a all over b minus a. I need to take the derivative of my function. So this would be power rule, 3x squared plus 2x. And I need to clean up that right side. That's going to be 2 over 2, which is 1. So I need to move the 1 over, and I need to factor this. Okay, yesterday we had to use the quadratic formula. This one does factor. Okay, 3x minus 1, x plus 1 equals 0. I get x is 1/3, x is -1. Notice both those answers. Again, I'm looking for some value of x. We're going to call it c. That fits in that interval. And when I plug it in for x in my derivative, I get 0. All right, and notice that both -1 and 1/3 are in that interval because I have a bracket around -1. So both those fits. I have two values of c that work there. All right. Next part, folks. I'm giving you ones now like. So those are our two regular examples for today. On homework set number 1, you can now do numbers 11 through 18. So I gave you a few that look just like a few of those homework questions. So one that's almost identical to number 12. It says verify the function satisfies Rolle's theorem. So first off, I just made a rough sketch of the graph. It's going to be continuous, and you're able to take the derivative on that entire interval. So just write something like that, like we did yesterday. Then you need to verify, part C there, the third part, the third hypothesis is very important. Plug 0 in for x, that's your A, you get 0. Plug 36 in for x, that's your B, you also get 0. So f of A is equal to f of B. Therefore, I know that f prime of C has to be 0. I need to find that C, or, as we saw in the other one, those C's. So I need to take the derivative of f of x, so I'm just going to rewrite this up here as this. And when I take the derivative, that's what I get. I'm going to clean it up. Remember, negative power means you put it in the denominator, okay? Now, I need to set this, my derivative, I need to set it equal to 0. Like I've done. Move the 1/6 over, do a little cross multiplication. 1 times this, 1 times this. Guys, if the numerators are equal, the denominators have to be equal there. Divide by 2, and then square both sides. 9 does fit in the interval 0 to 36. 9 fits in that interval. All right, so that's my value of C. That works. C equals 9. Not too difficult, folks. And take a look. This one's like number 11. All right. So on 11, so like 11, again, this is very similar to 11. We're going to do the same thing as number 12 here. Okay, so it does make it does make that lovely U right there. So it's continuous and differentiable on 0 to 6, that interval. F of 0 is 11, and f of 6 is also 11. So that third hypothesis of Rolle's theorem is true. So I need to find f prime of some c, and that equals 0. Okay, so I'm going to take the derivative of f of x, right up here, take the derivative. It's negative 18 plus 6x, and I need to set it equal to 0. All right, move the 18 over, x equals 3. And folks, 3 is in an interval. It's exactly in the middle. Because when I get that lovely graph, folks, remember, when the derivative, when you get a point and you evaluate the derivative and it's 0, it means you're going to have some sort of turning point. It makes sense that it would be my minimum in that graph. And we're going to learn more about that on Monday. All right, that's not a coincidence. So C would be 3. My value, my C would be 3. Guys, there is something interesting on number 14. Remember, you could get a no solution type. All right, remember, if you use the quadratic formula and you get an imaginary answer, then it's no solution. It doesn't exist. There is no value. Okay, so hint, hint, wink, wink. Remember, for the mean value theorem, folks, f of A does not have to equal f of B. F of A does not have to equal f of B. Okay, you simply use this right here. All right, and folks, that is it. So take your time, go back, rewatch these, and I want you to try 11 through 18 on your homework. And that is it. This is Yak Math Videos signing out.